Have you ever been curious about how predicates work in Java? Are they just a replacement for if conditions, or is there a bit more to it? I'm Saeed, the codogrammer, and in this video, we're going to go into how to practically use predicates in your code. So let's get straight into it. So here's an example of a predicate. If I click into there, you can see that this is part of the Java util function package where other functions such as supplier, consumer function, all of those live. Okay, and you can see that it has a type parameter here, a generic type parameter. So this is a predicate that works with objects. So let's just click into there and have a look. And the most important method that we are interested in is this test method here. So the generic type T is passed to the test method, and that returns a true or false. And lambda implementations of a predicate will define the functionality for the test method. So predicates allow you to pass around a piece of code. Now, all of the functional interfaces in Java, if I just click back into here, you can see that this is a functional interface. Now, all of the functional interfaces in Java, wherever they're declared, instead of passing a value of some type, you can actually pass a piece of code, a chunk of code, for that method to execute whenever it's appropriate. So instead of passing a true or false value, you can pass a predicate, which allows that method to execute that predicate against some value. In this case, this predicate is executed against an object because that's the type that's declared for it. And one of the key benefits is that they can be executed later. So as we've said already, it's a functional interface and it is not necessarily a replacement for an if condition. So let's have a look at some examples. We have a cook method. Now let's say we're in a restaurant setting. We have to be quite careful that customers who come in who have allergies to particular ingredients are not harmed. So we don't want to cook something that contains an allergen that some customer is allergic to. So we have this cook if safe method. Now if I click into there, the cook if safe method wants to only cook if the ingredients are safe for that customer. Otherwise, it won't cook because there are some allergens in that food for that customer. Now, what allergies people have are different. One customer may have no allergies, another may have a very long list of allergies. So we want to pass in a predicate because we don't know exactly which allergens to test for up front. Okay. Now, in this example, we have a customer who has a nut allergy. So we define the predicate by saying R, which is the recipe, is nuts, which means does it contain nuts? So it's not very well named, but does it contain nuts? So in this case, it will go into here and this will execute that particular predicate against, I should say recipe, against this recipe, and it should not cook. So let's just comment these out for a second and we can execute that. All right. All right, so that didn't do what we wanted because we got the condition the wrong way around. So if the test returns true, that means it contains some allergens. So this should really be down here and we can move this up here. So if the condition is true, that means it contains some allergens. So let's run this again. All right, the result is let's cook. And that's because this recipe here is empty. We didn't give it any values. So definitely is nuts is false because, well, we didn't set any values on it. So is nuts is going to be false by default. So that means it's safe to cook even if the customer has a nut allergy. All right, so this is essentially the same as this because this type of simple lambda can be replaced with what we call a method reference. Now, for all intents and purposes, these are effectively equivalent. There are some subtle differences, but not important enough for us to discuss at this point. So in both of these cases, we pass a condition down. Instead of evaluating the condition up front, we pass the condition down to the cook if safe method. The cook if safe method applies this condition to a recipe, which happens to be this recipe. Okay, so we can see that if we click into here, you can see that it takes the recipe and takes the predicate and applies the recipe to the predicate's test method and then evaluates a condition. Now, the benefit of this is that we passed the condition down and it applied that condition to the value as and when it was required. We didn't evaluate that up front. And we can have the logic in here to do the various conditional testing. So the benefit of having a predicate here is that we don't need to hard code what type of conditions we want to check for. For example, in this case, a nut allergy. We may have customers with additional allergies or different allergies. Okay, so for example, we have a customer that's allergic to nuts and gluten. So we can say that if R is nuts or if R is gluten, then we've got a problem and we don't want to cook. So let's just execute that and see what happens. Yep, again it says let's cook because in this case we pass it an empty recipe which doesn't have any nuts and doesn't have any gluten, so it passes and the condition is true. Alright, so hopefully you can see that instead of evaluating a specific condition, to declare a predicate against a recipe as an argument to this method means that this method becomes instantly more flexible. We don't have to specifically check every time for particular allergens. We can just check for the allergens that apply to a particular customer. You could even have a condition here which always evaluates to true. In other words, the customer has no allergens, in which case this will always pass as true. And you could declare that by doing something like this. Okay, so you can see that this one method, we've been able to use it flexibly for somebody who has a nut allergy. We've also been able to use it for someone that has a nut and gluten allergy. And we've also been able to use it for someone that has no allergies. So hopefully you can see the benefit in that. Now I have seen occasionally in certain code bases where they treat predicates as if they are a replacement for if conditions. Personally, I don't think that's the best way to go. So you can use something like this. For example, if we want to print out whether a string is longer than 3 characters or not, we can declare a predicate called is longer than 3, which takes a string and just checks that the string length is greater than 3 and then prints out true or false. In this case, blah, so it should be true. Okay, so longer than 3 would print true against this predicate here. Now, if you use it like this, you end up declaring an extra reference type, which is this here, all for the sake of a condition. And you don't really get any benefit from deferred execution because you execute the test immediately afterwards. Okay, so me personally, I think a simpler way to do that is to just have an if condition. So in this case, we say is longer than 3 is false. Then we say if this string's length is greater than 3, then we set this to true and we just print that out here. And you could simplify that even further by just not having this if condition, but just declaring the condition inside brackets here. All right, so just to recap, a predicate is a functional interface that has one type parameter. It executes some condition against a value that matches this type parameter. And essentially, predicates allow you, and all functional types allow you to pass a piece of code around. In this case, it's a condition that executes against an object that returns true or false. It's not a direct replacement for an if condition. You can use it like that, but really there's probably more elegant and cleaner ways of doing it. So I hope you found this video useful. If you did, give it a thumbs up. That lets YouTube know that this might be useful to other viewers. And for more tech tutorials, developer news, software industry news, make sure you hit subscribe so you don't miss out on future content. Thank you for watching.